Hey everyone, this is Alex here. So today I bring you another little project. As you may know, there are no lengths that I wouldn't go to solve the most seemingly insignificant problem that there are in the biology lab. Problem for me. There are times where I want to make aliquots, so portion out different reagents, let's say, I don't know, 100 times, and I want to transfer, let's say, a liquid from a larger stock to 100 of these little guys right here. So why would you want to do this? Well, I mean, if you're a lab tech and you're preparing samples for, hundreds of students, it could be very valuable there. Or if it's, for lab purposes, for basic research, it could be good because when you're setting up reactions, it's very, very good that you take fresh stocks of reagents almost every time, such that if you accidentally contaminate one of your stocks, you just throw it away. I'm going to regret that. You just throw away your stock and start with a fresh stock and you're good to go. So this is why you may want to have lots of little aliquots of different reagents. You lose money in terms of the little Eppendorf tubes or microcentrifuge tubes, but I think you save money in the long run by having less failed experiments. So that's essentially what I want to do. I want to take a large stock and I want to divide it in lots of little tubes. So how I traditionally do this is with a mechanical pipetter, or I guess a manual pipetter, and you take 1 ml and you transfer it to the tube. And let me go get that little tube. So I would take a ml of liquid, put it there, close it, put it down. Not so bad, right? Well, do that 100, 200 times, and it's just a pain. It's just a pain. You know what? It's not that bad, but if I could find a way to automate it, that would make my life a whole lot easier. Now, the way the way that I want to solve this specific problem, or how somebody in the industry would do this, they would get what's called a liquid handling robot. And a liquid handling robot is essentially you're replacing a human being with a robot that has some sort of pipetter on it, and you essentially program it. So intuitively, it's not, mechanically, it's not that complicated. However, obviously, a proper liquid handling robot, take a guess, 5, 10 grand, 20 grand. It's one of those things where if you have to ask, you can't really afford it. So, I don't know. It's one of those things where you have to ask for a quote before you know what the price is, so you know it's going to be brutal. But, I don't have that kind of money. So, essentially, what this project is supposed to be is to bring liquid handling at a low cost to everyone, starting with me because I'm going to build it for myself, but then for everyone at a very, very low cost. So, how I intend to do this: first, I'm going to get an electronic pipette, aka this one. I am going to hook it up to the cheapest 3D printer money can buy. I'll get a better view later, but basically it's a 3-axis CNC machine, or, well, CNC machine. So there's the bed. This piece moves up and down, and this goes left and right. And how this would work is essentially you have your electronic pipette, and I have 3D printed a specific mount for this specific pipette. Again, if you're gonna do this, you should probably come up with your own designs. I will put up exactly how I made my own, but don't take my word as gospel. Basically, I want you to be able to grab off-the-shelf parts, throw them together, and have a working, working piece of equipment. But anyway, so this mount is made specifically for this pipette. I don't know if it'll fit anything else, but basically, okay, this is the best angle I can manage right now. I'm not a cinematographer, so if you came here for this, then anyways. So yeah, the pipette mounts in here quite nicely, and then goes left and right, up and down, and then the actual plate moves backwards and forwards. So the way that I picture it is I would have everything set up here. My pipette would move to the liquid and then take whatever 1 ml and then put it inside that little tube. And that's all I wanted to do at the beginning. And I'll take the pipette apart so you can see how it works in a second, but let me go over, or actually, you know what? Let me take the pipette apart first, just so you can see how to wire it so that you can control it from a computer. And then I'll show you future pitfalls that I envision with this little project. So the pipette that I chose, it was honestly the first one that was a reasonable price on eBay. It was something like $80 shipped, and it seemed in reasonable condition. I didn't care about the battery because we're going to be powering this externally. As long as when you're shopping on eBay, just make sure that the person says that at least it works, it turns on, it doesn't throw an error, because you don't want to buy this and have to fix it. But this is ePet, a BioHit ePet. I think they're also sold by Sartorius or something like that. But yeah, inexpensive, but looks like pretty good. And so as you can see, I chose a pretty wide range. Not too minuscule, so 50 microliters is a good amount, all the way up to 1.2 ml. So it should cover the majority of my aliquoting needs. And by the way, as a sort of, I guess, pun, I'm calling my aliquoting robot the Aliqbot. So there you go. I think it's a cool name, but yeah. So the pipette, ePet by BioHit, stroke Sartorius. To take this guy apart, first of all, there's just 4 M2 Phillips screws here. So nothing too difficult. Just don't lose them. And if you're wondering why I wear gloves all the time, I think working with RNA gives you different types of neuroses, one of which is you feeling dirty touching anything without gloves. Oh, I got a lot to tell to my therapist. So when you remove these top 2 screws, the battery door pops open. I've already had a crack at this, so I just have the battery in here as a spacer, just to provide some spacing in there. I should probably replace it with something more inert, but it's a prototype, right? Then it's pretty easy to just lift off this front cover. And of course I've glued, being the genius that I am, I've glued everything together. And here's the actual innards of the pipette. Ooh, there you go. So actually nothing too crazy. you've got Atmel ATmega 169. It's a funny number. 169 Atmel microcontroller, so that's actually doing all your thinking. I think there are some motor driver chips here. There's one motor back here, and there's also a little solenoid that stops the motor from turning like a physical block. And basically, the reason that I chose an electronic pipette versus, let's say, on Thingiverse, you'll find different attachments for the 3D printer, which will take a syringe, and you can control a syringe with a 3D printer. I didn't want to mess around with, first of all, printing that and then calibrating it, because, you know, first of all, you have to tell it, okay, move the motor this many steps to bring up a certain amount of liquid and then dispense a certain amount of liquid. And it's not really optimized to repetitive sort of liquid handling like an actual pipette is. And I think for $80, this has saved me sort of a lot of time in calibrating and developing the actual liquid handling mechanism. So it's all included here. I don't have to do any additional work. I just literally, you know, throw this on a 3D printer and then get to work. Normally, you would actually suck up and dispense the liquid with a button that lived here, which I took out, but it would make contact with, so it would make contact with this pad here. But obviously, it's not much of a robot if you need to click the button every time. So what I did was I soldered two tiny little enameled wires on each side of the, what do you call it, the pad, and just broke them out so that I can connect them. Basically, every time I short out these two wires, bring them together, this pipette will sort of actuate, it will work. And the other buttons also still work regularly, so, you know, I set the pipette up manually to do 1 ml portions, and then everything else is controlled with the computer. So like I said, nothing too complicated here. Here, I guess let me show you how it actually works. I had already broken this and fixed this, obviously, so I'm a little wary about taking it apart again, but if it's for science, then what can I do? So the board's actually kind of nice. It comes apart in a nice little unit, and what connects it to the rest of the pipette. There was another little wire, but I cut that off. These two wires, they connect to this main motor here, and that's what actually drives the displacement of the pipette. So this motor is geared onto, there's an internal sort of threaded shaft here, and a plunger, piston, that goes up and down and displaces the liquid inside, displaces the air, the volume inside this portion of the pipette, and therefore whatever liquid that you're trying to handle. So this motor spins. It spins a threaded rod in here, and that actuates, hold on, I can take this apart. And that rod activates this little piston, and it has an O-ring which seals on the inside of the actual, I guess, pipette tip, and that's what displaces the volume for your actual pipetting. And this, it's kind of interesting. You also have a solenoid here, which attaches directly to the board with these two, I guess, prongs. and it keeps this motor from turning. So it's just part of this mechanism, however they got it set up so that the pipette can't, I guess, tear itself apart. It's a physical sort of block in front of the motor that stops it from turning. So I'm going to carefully reassemble this thing and probably rewire this. The wires here are way too heavy for for the current this is handling. I'm gonna make it look a little nicer, put it back together, and I'll demonstrate how to actually turn this thing on and off. Okie doke, well that doesn't look half bad. So I've just got all the wires coming out to this cord with 4 wires. You have the two for power, the red and the black, and then you have your 2, I guess, signal wires, which we're essentially going to be shorting together to actuate the pipette. Now, I have this powered with a sort of, I don't know, adjustable power supply. This is just for prototyping. When the robot actually gets put together, this will be replaced with just a regular sort of single voltage power supply. But as you can see, it's running just fine at 7 volts. And at least to me, it seems that it'll run between maybe 5 and 8 volts is probably, it's got a pretty good range on it depending on your power supply. But anyway, so it's on, and I've adjusted the volume down a little bit. And the way that we're actually going to tell it, because the button's gone, it's long gone. So how are we going to tell it to actually actuate the mechanism? So I've also broken out the wires for the signal, and literally all you do is you short them together like that. And if you heard that, the pipette just went. So let me just put that back to the standby position, and then I'll show you actually pipetting some liquid. So just got a little beaker here full of water, and I figure let's add a little bit of bromophene blue for excitement's sake, and you don't need that much, just a little speck will do the trick. Yeah, a little speck like that is enough for the demonstration. More of a purple color actually, but okay. And just so you know that it's working, I'm gonna try to do this. So, as you can see, it works just fine. And essentially, this allows me to focus on what will be the bigger program, or the bigger problem, which is programming this little beastie to do what I want. The actual mechanics of a liquid handling robot are not that magical, really. It's going to be all in the programming, which we'll talk about in 1 second, but just dispense that. Woo! Look at it go. Nice. Okie doke. So basically this wire, or this entire pipette, is going to be mounted to the 3D printer, and that's going to comprise the pipetting robot. So let me just turn this off. Okay, so rather than sort of going gung-ho into the project where I might have done when I was younger, it's always good to think about what are the potential downsides of your project. So one of the upshots is that a electronic pipetter and a 3D printer, which together we'll call the Aliqbot, Overall, mechanically, it's a pretty simple design. So basically, all you have, it's an X, Y, Z moving robot that has a pipette attached. That has a pipette attached, and that's all a liquid handling robot is. It's essentially just a robot that moves in three dimensions and then takes and dispenses liquid. That's it. That's all there is to it mechanically. But by far the biggest challenge that I see with this project sort of going forward is the actual programming part. The companies that make these sorts of robots, they don't publish their software, and we can sort of rule that out right now. There is one, I guess, free software called Andrew Lab, but I believe it's only for their specific robots, so not much use there. So essentially, we're going to have to tell the robot where to go, when to take up liquid, when to dispense liquid, and repeat that, however many times. And I'm not the best programmer in the world. I just copy and paste and cut bits together until the program basically works. So for me, this is going to be the most challenging part. And my goal of bringing it to a greater audience is going to require that this robot, it's easy enough to build. You can build it in an afternoon, but that this robot also be easy to use. So maybe have sort of like a touchscreen interface, where you have, let's say, your main reservoir, and then you have your rack filled with little tubes. And the hardest part is, first of all, I have to figure out how to program a GUI, then actually telling the robot to go X and Y a certain amount to the block holding your tubes. It isn't going to be too difficult. What is going to be difficult is the Z height, so the up and down height. So let's say I have a tube that's this shape. So it's got a even or a constant diameter up until it gets to the bottom, after which point it becomes sort of sloped. So if the liquid level is going to start at about here, and then the pipette is going to just, for good practice, you want your pipette to dip maybe 1 or 2 millimeters into your liquid, and then it's going to take whatever, 1 ml, and it's going to transfer it to a tube. And then when you do that, when you take out a little bit of liquid, that water level is going to drop just a little bit. So not only do I have to tell it, okay, go to the reservoir, take 1 ml, it also has to take into account how much it's already taken out. It has to take into account, the volume and the dimensions of the tube. It has to take into account any sort of variations in the tube. So you have a constant diameter here, and then you have a decreasing diameter here. So at least for me, that's going to be the hardest part to program. I suppose I'll have to design it around a set of standard tubes. Otherwise, you'd have to build in some sort of image recognition robot that could actually read how how much liquid that you have in a tube. So you'll have your standard, like 50 ml sizes, your 1.5 ml, your 0.2 ml, and what else? Maybe something like this, maybe 100 or 150 ml beaker or something like that. So that's probably all going to have to be hard-coded into whichever type of program I decide on, maybe Python. Ideally, this would be running on a cheap Raspberry Pi with a cheap touch display and have it all sort of being able to program by touch, because while I may enjoy writing stuff out in G code, I realize not everybody has the time, the patience, or the proclivity for that sort of activity. So having a nice graphical user interface, take it from here. You'll probably have to manually adjust the starting point. I guess that's not too bad. Start the starting point, tell it what size tube the reservoir is, then where the destination tubes are, how many they are, what type they are, and have that all sort of like touchscreen compatible. This is going to be a big project. I'm not a huge programmer, so we'll see how it goes. But at least for now, literally all I wanted to do, again, just to help me out, I wanted to take water from the master stock, and then I wanted to just aliquot it into small tubes. Hell, maybe if I even hold the tube in front of it and press a button for it to dispense, that would be okay too. Just something to reduce the amount of pipetting that I do if I'm going to make 100 or 200 little mini stocks of something. So that's the sort of basic idea and where I see this project being actually quite difficult. Let me get it to the point where it's doing exactly what I just said. So taking 1 ml of water from a large reservoir and putting it into a smaller tube. So once I get that running, I think that's where I'll show you that, and that's where we'll leave part 1 of the video. Okay, and here we are all mounted up. This will be moving soon, so... And then... Okay, so today is tomorrow, and I finally got the Aliqbot Mach 1 working to the point where it actually does what it's supposed to do. So I've set it up, the G code, to transfer 1 ml of liquid from this container right here and transfer it to an Eppendorf tube. Oh, spilled water everywhere, that's good. To an Eppendorf tube that I'm holding. So let's try that right now. Thank you, Aliqbot. Ta-da! Now repeat that 100 more times. So not a bad machine after all. However, I have to say it's much slower than I'd like. So I can make an aliquot like this in maybe 5 seconds, whereas that whole process, I'll just let it run again, takes about 15 seconds. Come on. So it's much slower than I would like. I think that the only way that you can increase the speed of this thing is by getting better stepper motors, because if I try to run the Z-axis stepper motor, which is what's taking most of the time, so the up and down motor, the motion, the motor actually stalls out because it's not meant to actually travel that fast. So I could put a bit more money into it and get a better stepper motor. So that's certainly possible. What else? Perhaps get a better stepper motor drivers, but yeah, I guess the forte in this thing is not the fact that it's fast, it's the fact that you can program it. So I think I'll probably just leave it like that for part 1. And in part 2, I'm going to have it maybe fill up a rack of little Eppendorf tubes instead of just one. For those curious of how I actually actuate the pipette, so the pipette is connected through with power. So there's power coming in here, 7.5 volts. But then also the 2 wires which are connected to the actuation button, they're actually connected to a very, very small transistor. There's a little transistor there, a PNP transistor. And that's connected to the spindle motor enable of the CNC Arduino shield. So that's basically how I drive it. And then the way that I program it is with this program known as BCNC. And basically, I've written up a little code. I've written up some G code to actually do all the movements and stuff like that. So for a better version of this sort of machine, you would have it integrated sort of into a GUI versus trying to piggyback off of G code and a CNC controller. But for a quick and dirty prototype, it's actually worked out better than I expected. However, it's probably too slow for what I intended it for, but I think it's fast enough for setting up 50 tubes in a rack, then pressing a button and then walking away. It's not fast enough where I can hold a tube in front of it and it'll do that, because I can make that sort of Aliqbot. I can make that sort of Aliqbot. Thank you for supporting me and my endeavors. I can Aliqbot that in 5 seconds. So this machine is pretty slow for what I wanted it for, but good enough for what it could be. Okay, so just a couple of more closing comments and more pitfalls that I encountered, so that if you try to recreate anything I'm trying to do, that you may make better choices than me. First of all, the 3D printer I chose, it's called the Tron XY X1, and I got it because it was cheap and it looked cute. However, it is unfortunately a little bit too small. As you can see here, I can't put the reservoir on the moving bed. It has to be off to the side. And I've also had to take off the larger bed to actually get the reservoir to fit within the motion of the pipette. So it's a little bit small. As well, because it's so small, the pipette can only travel upwards so far. So the Z travel can only go so far, which means that there's a limit to the height of things you can put underneath it. So if you're going to do this, I would recommend getting a bigger but still cheap 3D printer. Another issue that I'm sort of working on solving is that the actuation of the pipette, it seems to be a little bit, I would call it noisy. I think that the signal wires, which actually simulate a button press, they are actually picking up some sort of electrical noise from the motors. And as a result, the pipette is actually triggering when I don't want it to, so it'll be moving up and it'll just start dispensing in the middle of nowhere, which is pretty embarrassing when that happens, right? So yeah, the printer's a bit small. The actuation probably needs some sort of filtering or protection against noise. What else? And yeah, so I think that's pretty much it for, potential pitfalls that you will encounter. That's where I'm going to leave the part 1 of this. I plan to make this into sort of a series to develop this robot a little bit further, because as I said, it's a bit too slow for manual sort of holding the tube in front of the tip and waiting for it to dispense. I can do that much faster by hand. But what I plan to do in part 2 is attach this, one of these types of trays, so that you can essentially set up a bunch of tubes, hit a button, and then it'll actually go into each individual tube and dispense it for you. So yeah, if you have any questions or comments or feedback, just leave them below, and thanks for watching. I appreciate it, and have a nice day, okay?